Hello everyone. Hope you are doing very well. So today we are going to see the theory part 13 of the chapter Haloalkanes and Haloarenes. So let's begin today's topic. NCERT chapter 6 Haloalkanes and Haloarenes theory part 13, and today we are going to specifically cover the section 6.8.4 to 6.8.6. This is disclaimer. Objective. So today's lecture objective, after attending this lecture, you will be able to highlight the environmental effects of polyhalogen compounds. So in the previous lecture, we have covered some of the polyhalogen compounds along with their environmental effects, health effects, and their uses. Today, we are going to further continue in the polyhalogen compounds along with their uses, environmental, and the health effects. The topics we are going to cover today according to the NCERT. First of all, the section 6.8.4, tetrachloromethane, or you can also call it carbon tetrachloride. Then we will cover the section 6.8.5 of Freons. And then we will talk about the section 6.8.6, P prime dichlorodiphenyl trichloroethane, that means DDT. And lastly, we will practice an exercise question 6.13. So let's start with our first topic, tetrachloromethane, which can also be known as carbon tetrachloride. Okay, and this is section 6.8.4. So let's see its first of all structure, uses, and health effects of tetrachloromethane. If we talk about the structure of CCl4 or carbon tetrachloride, the structure is something like that. This is a single compound, a single carbon compound. Okay, that's why we are calling methane. Okay, so this is a single carbon compound, and its tetravalency is occupied by 4 chlorine atoms. Okay, so with like each bond is forming between chlorine and carbon. Okay, and this is a polyhalogen compounds. The compound which contains more than one halogen atom are considered as polyhalogen compounds, right? So this is a polyhalogen compound because it consisting of 4 atoms of halogen, right? So this is tetrachloromethane, which is a polyhalogen compound, and this is its structure. Now, if we talk about the uses of tetrachloromethane, it used to manufacture the refrigerants and propellants for the aerosol cans. So we use the tetrachloromethane as a manufacturer of refrigerants. Refrigerants are basically, you can say, they are chlorofluorocarbons that are used in the AC, okay, air conditioner and the refrigerators. Okay, and also you can say that they are used to transfer the heat in the cooling systems. And also the propellants are basically, you can say, fuel that cause something to move forward. Okay, so for the aerosol cans, aerosols are the small particles suspended in the atmosphere. So for the aerosol cans, the tetrachloromethanes are used as a manufacture of are used to manufacture refrigerants and the propellants for aerosol cans. It also used as feedstock in the synthesis of chlorofluorocarbons and other chemicals. Okay, so we also use it as feedstock in synthesis of the chlorofluorocarbons, CFCs, and other chemicals. Pharmaceutical manufacturing. So this tetrachloromethane also uses in the pharmaceutical manufacturing. Okay, so in the medical field, in the pharmaceutical field, in the manufacturing of some compounds, tetrachloromethane is being used. Also, it is used as a general solvent. Okay, so it's one of the uses is general solvent use. Until mid 1960s, It is widely used as a cleaning fluid, degreasing agent, spot remover, and fire extinguisher. So until the time of mid 1960s, okay, mid 1960s means up to 19, you can say 55, okay, the tetrachloromethane are widely used as a cleaning fluid. Okay, we use this tetrachloromethane in the cleaning purpose, like it is used as a degreasing agent or as spot remover. Okay, the word are explaining everything. And also the carbon tetrachloride was used as fire extinguisher at that time. So these are the major uses of the tetrachloromethane in today's time as well as in the previous time. Now let's see its health effects. So if we come in contact with the carbon tetrachloride, then what will be the health effects of the consumption of this you can say polyhalogen compound? First of all, it causes liver cancer in the human. So carbon tetrachloride is so dangerous, it causes liver cancer in the humans. The common effects of the exposure of carbon tetrachloride are dizziness, lightheadedness, nausea, vomiting, and it can cause permanent nerve cell damage. So in your brain, it can even cause a permanent nerve cell damage if you come in contact with the carbon tetrachloride. So these are some common effects of the exposure of carbon tetrachloride. Okay, so severe cases is rapid stupor, coma, unconsciousness, or even death. So it is the carbon tetrachloride is even your it can even cause the death of the human being. Okay, so this is so harmful. It can make the heart beat irregular or stop. Okay, that can ultimately cause to death. So if you comes in the contact with the carbon tetrachloride, it can make your heartbeat irregular, and even it can stop your heartbeat and cause the death. It may irritate the eyes on the contact, and if it comes in the contact with the eyes, it may irritate them. Now let's talk about the environmental impact. So these are health effects that if we come in exposure of the carbon tetrachloride or tetrachloromethane, then what are the effects on our health that are going to be, that we just have discussed, that is so harmful. It can cause death of a human being. It can cause liver cancer. Okay, let's talk about the environmental impact now. That what is the environmental impact of the carbon tetrachloride presence? So it depletes the ozone layer when released into the air. So if the carbon tetrachloride is released into the air in the atmosphere, it can deplete the ozone layer. Ozone layer is basically a layer above our troposphere layer. Okay, so above the layer of troposphere, we have this ozone layer which protects, or which radiates the UV light coming from the sun directly towards the earth. Okay, so what this ozone layer do, this protect the earth. Okay, this layer protects earth, peoples or us from coming in the contact of UV rays, ultraviolet rays, which are so harmful, which can cause the skin cancer or skin damage. Okay, so if you use, or if this carbon tetrachloride release into the air, it can deplete the ozone layer. Ozone depletion, if there is any depletion of ozone layer, then it will increase the human exposure to ultraviolet rays, UV rays, leading to increased skin cancer, eye disease, and the possible immune system disruption, because UV rays is invisible. They just come directly from the sun, and if there is ozone depletion, they directly can enter into the atmosphere of the earth and can reach towards the people, can come in contact with their skin, their eyes, their immune system. Okay, and it can destroy everything. It can cause skin cancer, eye disease, and can possibly disrupt your immune system. Okay, so this is the you can say cause of the ozone depletion, that if there is any depletion of ozone, it will increase the human exposure to the UV rays. UV rays can directly now expose to the human beings without any protection of the ozone layer. Okay, so environmentally also, the impact of the carbon tetrachloride presence in it is also so dangerous. It can deplete the ozone layer, which is going to harm the human due to the direct exposure to UV rays after. Now let's talk about our another polyhalogen compounds, that is freons. It is section 6.8.5. Now the same thing, let's talk about its structure, uses, and the environmental impact of freons. If we talk about its name, so it is also known as chlorofluorocarbons. This is more common name than freons. Chlorofluorocarbons is the other name of the freons. Chlorofluorocarbons, CFCs. Okay, synthetic chemical compounds consist of carbon, chlorine, and fluorine. So freon is basically a synthetic chemical compound. What does it mean? That it is made up, it is not naturally occurring. The freon is not naturally occurring, it is made up by the human being. Okay, so that's why we are calling it as synthetic. So this is a synthetic chemical compound in which it consists of carbon element, chlorine, and the fluorine halogen. Okay, so this is freon is also known as chlorofluorocarbons, and it is consisting of carbon, chlorine, and fluorine majorly, and it is a synthetic chemical compound. If we talk about the structure of freon, which is CF2Cl2, the molecular formula of freon is CF2Cl2. So what we are saying, that this is a single carbon containing compound, and the two valencies are occupied by the fluorine, the other two valencies are occupied by the chlorine. So one carbon attaching with two chlorines atom and two fluorine atom. Okay, so we are calling it as chlorofluorocarbons, or more commonly freons. Its characteristics, so the freons are extremely stable, unreactive, non-toxic, and non-corrosive, easily liquefiable gases. Okay, so these are the some characteristics, or you can say properties of this freon, that it is extremely stable. That's why the human being is able to or capable of to make it, right? This is a synthetic chemical compound, remember? So this is extremely stable, this is unreactive, this is non-toxic, non-corrosive, and it can easily liquefiable. It can easily be liquefiable. So it is an easily liquefiable gas. Liquefiable means it's solid, can be transformed to the liquid, often by heat or even applying pressure. Okay, so freon 12, it is a type of freon. Okay, so freon 12, which is CCl2F2, the same molecular formula, it is a common industrial freon which many industries use in the manufacturing of their compounds. So the freon 12 manufactured from the tetrachloromethane by this particular reaction called Schwarz reaction. Okay, so freon 12 is a category or is a type of freon, and it is a common industrial freon used industrially, okay, in the major volume. So this is a common industrial freon, and it is manufactured by the tetrachloromethane molecule by doing Schwarz reaction. What this reaction is, so we take the tetrachloromethane. Tetrachloromethane means single carbon compound having 4 chlorine atoms. Now when you add this tetrachloromethane with antimony fluoride, 2 molecules of SbF3, they react with each other and they will cause for the formation of freon, that is CCl2F2, plus antimony triachloride, that is SbCl3. 2 molecules will be your byproduct in this reaction. So this is a Schwarz reaction. Okay, this includes the manufacture of manufacture of freon, okay, CCl2F2, that is chlorofluorocarbons having formula CCl2F2, and this manufacturing of freons is from tetrachloromethane, and this is a common industrial freon which many industries manufactured and uses industrially in a large amount, in a large scale. Now, if we talk about the uses of freons, so it is an aerosol propellant, okay. So you have observed that many of the polyhalogen compounds are actually aerosol propellants, okay. So freon is also an aerosol propellant. It is a kind of fuel. It is also used in refrigeration. As I said, that freons are refrigerant that are used to transfer the heat in the cooling systems like refrigerator or can say air conditioner, okay. So freons are used as in the refrigeration. It is also used in the air conditioning as a refrigerant. What are the environmental impact? Or if the freon is released in the environment, then what its impact on the environment? So eventually it will diffuses unchanged into the stratosphere, okay. Eventually diffuses unchanged into the stratosphere. So the stratosphere is the layer which is just above your troposphere, okay. So above the troposphere we have a layer of ozone layer, and this ozone layer is in the stratosphere, okay. So the freons, when we are using the freons in our daily life as in refrigeration or in the air conditioning, it eventually diffuses unchanged, that means as it is, into the troposphere layer. Initiate radical chain reactions in the stratosphere that upset the natural ozone balance. And what will happen? So as it is diffuses into the stratosphere, and there it initiate a chain reaction, or you can say radical chain reactions, where it upset the natural ozone balance. So the ozone layer presence in the stratosphere is going to be unbalanced, is going to be disturbed by this radical chain reaction performing by the freons, which are diffusing into the stratosphere via the regular use of the freons in our day-to-day life. Total production by 1974 was about 2 billion pounds annually. So this much amount of freons was producing up by 1974. So it was so before, right? We are right now in 2020s, right? 2025, okay. So it was so before, like in up to 1974, the production of the freons was about 2 billion pounds annually, that is per year, okay. So the earth is producing 2 billion pounds per year up to the year 1974, and after that we are increasing the use of freons because we have increased the use of this refrigeration and air conditioning and this cooling systems in our day-to-day life, due to which the production of the freons will also increase into the environment, which will cause the impact on the environment as bad, okay. Because as we have seen that from our you can say cooling systems, it will diffuse unchanged into the stratosphere layer, which is just above the troposphere, and troposphere is just above the earth. So above the earth we have troposphere, then we have stratosphere, okay. In the stratosphere there is ozone layer presence also. So what will happen, freon will go directly into the stratosphere unchanged, and then there it will initiate a radical chain reaction in the stratosphere, which is going to upset, which is going to disturb the natural ozone balance. So it is going to disturb the natural ozone layer which is present in the stratosphere and cause us harmful impact on our health, okay. As we have just seen that depletion of this ozone cause the cancer, skin cancer and eye disease, okay. So this is the environmental effect of freon. Okay, now let's see the DDT, that is PP prime dichlorodiphenyl trichloroethane. Our next section 6.8.6. Similarly, let's talk about its structure, uses and health effects. So if we talk about its discovery, so DDT, that is dichlorodiphenyl trichloroethane, was first prepared in the year 1873. Structure of DDT. So DDT formula, molecular formula, you can write it as C14H9Cl5. So it contains 5 number of chlorine atoms. So this is a polyhalogen compound. And if we talk about the structure, this figure showing the structure of DDT, you can see 2 chlorobenzene rings are connected with the carbon here, and this carbon is binding with this carbon, which is having 3 chlorine atoms over it, right? 3 chlorine atoms are attached to this single carbon, and this carbon is attaching to this carbon, which is binding with these 2 chlorobenzene rings. So this is the structure of dichlorodiphenyl trichloroethane, or you can say DDT. This is a polyhalogen compound. Now, if we talk about the preparation of DDT, that how can you prepare the DDT molecule? So the reaction happens in this way. We take chlorobenzene, because we can see that in the structure of the DDT we have chlorobenzene present. So chlorobenzene we take as a reagent, plus we react it with trichloroacetaldehyde, that is CCl3 C double bond OH. This is a aldehyde because CHO bond is present here. Okay, and also name has also aldehyde. So this is a aldehyde, and it is having CCl3, that means 3 chlorine atoms. Okay, so this reaction will happen, and what will in the presence of concentrated H2SO4 sulfuric acid, and you will got your final product as DDT. So these 2 molecules of you can say chlorobenzene ring will attach on this carbon over which double bond O is present, and after the charge balance you will get this DDT as your major product. You can see this carbon in the trichloroacetaldehyde having 3 chlorine, this is present like this in the DDT. Okay, so this is the process or reaction, you can say, happening in the presence of concentrated sulfuric acid, and this is giving us the formation of DDT, dichlorodiphenyl trichloroethane, a polyhalogen compound. Historical use, let's also consider its historical use. So previously the use of or you can say historical use of DDT was increased enormously worldwide after the World War II. So after the World War II happened, the DDT was used enormously worldwide. That means in a large extent worldwide. Effectiveness against malaria, spreading mosquitoes, and typhus carrying lice. So also after the World War II, there were so many health conditions, like there were mosquitoes which were causing malaria, which were spreading malaria in a large amount, and so this DDT was the molecule and it was very effective against these malaria spreading mosquitoes and typhus carrying lice. Effectiveness as an insecticide was discovered by Paul Muller in 1939, and he also won a Nobel Prize for this in 1948. Okay, so DDT is also effective as an insecticide, so kill the insects like mosquitoes and its lice. So this nature or this effectiveness of DDT was discovered by the scientist Paul Muller in the year 1939, and he was awarded by Nobel Prize in the year 1948. Problems with the extensive use. Now if you're historically if DDT was this much useful, then what are the problems with its extensive use in the late 1940s onwards? What are the problems that world has faced after the extensive use of DDT? Insects developed resistance. Okay, so basically the DDT is a insect resistant, right? It kills the insects. It is insecticide. It was used as an insecticide. So the first problem was that it was insects developed resistance. It is high toxicity. It is having high toxicity towards the fish. So due to the extensive use of it as an insecticide, it has developed its resistance, okay, against the insects. So the number of the insects, you can say, was like becoming lower, and also it is highly toxic towards the fish, okay. So when we use it as an insecticide, it kind of also can go into the waters, right, where the fish, the aquatic life, was affected due to the DDT, because it is highly toxic towards the aquatic life, towards the fish. Chemical stability and fat solubility led to bioaccumulation. Now also the DDT is chemically stable. It was chemically stable and it was fat soluble. Okay, that means if there is any consumption of DDT inside the animal as a fat, it will soluble as a fat. It will not dissolve. It will not break down. Okay, so it will lead to bioaccumulation. Bioaccumulation is basically a process where the substances, particularly toxins, like toxic like DDT, okay, build up in an organism over time, and it occurs when the rate of intake of a substance, here in this case it is a DDT, so when the intake or the rate of intake of a substance exceeds the rate at which the organism can eliminate or break it down, okay, then this bioaccumulation condition occur. So DDT was chemically stable and fat soluble, due to which it has led to bioaccumulation in various animals, okay, mainly in the fish. Okay, so it is highly toxic towards the fish. It leads to the bioaccumulation, which is basically the process where the substance, particularly toxins, build up in an organism over time, and it can't be able to break it down into the simpler molecules, okay. Not rapidly metabolized by the animals, so it can't be rapidly metabolized by animals, and it will be deposited and stored in the fatty tissues of the animals. Okay, we are talking about DDT. So DDT was so chemically stable and fat soluble, it will lead to bioaccumulation, which is why that animals can't rapidly metabolize this DDT, and due to which it will deposit and stored in the fatty tissues of the animals. Builds up within animal within continuous ingestion. So as more as like if the rate of the intake of this ADT is increasing or exceeding the limit of the rate of breaking or eliminating down the fats or molecules in the animal, so if this thing happens, if this condition happens, then in the animals it will build up with the continuous ingestion, okay, and this condition will lead to the bioaccumulation. Now if we talk about the current status, it is about the previous thing, like historical use we have seen, and after the extensive use of it as an insecticide in the late 1940s onwards, what will happen, that we have also seen. Now what is the current state of DDT? So it has banned in the United States, in the US in the 1973. So previously in the 1973 it was banned in the United States, but still in the today's time it is used in some other parts of the world as an insecticide. Okay, now let's talk about the some other halogenated compounds. So some other applications of halogenated compounds. First is chloramphenicol. This is a chlorine containing antibiotic which is produced by the microorganisms, effective for typhoid fever. This is the application of this chloramphenicol, and this chloramphenicol is basically a chlorine containing antibiotic. That means it is an antibiotic which is containing chlorine, and it is produced by the microorganism, and it is very effective for the typhoid fever which is caused by the, can say, mosquitoes. Next halogenated compound is thyroxine. Thyroxine is a iodine containing hormone. It is having a presence of iodine, and deficiency of this hormone, this thyroxine, cause the disease goiter in the human beings. Chloroquine. So chloroquine is a synthetic halogen compound. It is a man-made, not naturally occurring, and it is used for the treatment of malaria, a disease caused by the malaria causing mosquitoes. Okay, so chloroquine, a synthetic halogen compound. It is used for the treatment of malaria. So this is the application of chloroquine. And last is halothane. Halothane is again a halogenated compound used as an anesthetic during the surgery. So these are some halogenated compounds along with their applications. Okay, let's solve an exercise 6.13 question. So the question is, give the uses of Freon 12, DDT, carbon tetrachloride and iodoform. So we have asked about the 4 different molecules uses: Freon 12, DDT, carbon tetrachloride and iodoform. So you have given some time, try to analyze this question, and then we will see the correct answer. Okay, let's see. So first of all, let's see the uses of Freon 12. So Freon 12 is a type of freons, and its uses included. So Freon 12 is a diafluoromethane molecule, CF2Cl2 molecular formula, and it is commonly known as chlorofluorocarbons, CFCs. It is used as a refrigerant in the cooling systems like refrigerators and air conditioners. In the aerosol spray propellants, it is used, such as in the body sprays, in the hair sprays. It damages the ozone layer. This is the impact of the use of freons in the environment, that it damages the ozone layer, leading to the depletion of ozone layer. Now, if we talk about the molecule DDT and its uses, so DDT is a PP prime dichlorodiphenyl trichloroethane molecule, and it is one of the best non-insecticide, okay, in the historical time, and it is very effective against the mosquitoes and its lice. And due to its harmful effects, due to the toxic nature of the DDT was banned in the United States in the 1973 previously, but into today's time, in the various parts of the world, it has been still used as an insecticide. Now, if we talk about the uses of carbon tetrachloride, that is CCl4 molecule. So it is used, the CCl4 is used for manufacturing of refrigerants and propellants for the aerosol cans. Okay, so CCl4 is used for the manufacturing of some refrigerants and also for propellants for the aerosol cans. CCl4 is also used as feedstock in the synthesis of chlorofluorocarbons and some other chemicals. It also used as a solvent in the manufacture of pharmaceutical product. Until the mid 1960s, until 1955 you can consider, carbon tetrachloride was widely used as a cleaning fluid because of its nature or because of its property of using as a degreasing agent, and also a spot remover or spot remover in the homes, and also as a fire extinguisher it was used previously in until the mid 1960s. Okay, so until mid 1960s the carbon tetrachloride was widely used as a cleaning fluid, as a degreasing agent in the industries, as a spot remover in the homes, and also as a fire extinguisher used to prevent from the fire. Now let's talk about the uses of our fourth molecule, that is iodoform, CHI3. So iodoform was used earlier as an antiseptic. Now it has been replaced by the other formulations containing iodine due to its objectionable smell. So in the previous time, iodoform was used as an antiseptic, but in today's time it has been replaced by some other formulations which is containing iodine. Why? Due to its objectionable smell. So it has something uncomfortable smell, objectionable smell, due to which it has been replaced by some other iodine containing formulas or other iodine containing compounds. Antiseptic property of the iodoform of CHI3, it is only due to the liberation of free ions, or you can say free iodines, when it comes in the contact with the skin. Okay, so it comes or it has this antiseptic property, the iodoform, because it is having this ability of the liberation of free iodine when it comes in with the contact with the skin. Okay, let's see the summary what we have covered today. We have first of all covered the topic polyhalogen compounds. In like polyhalogen compounds are the carbon compounds that are containing more than one halogen atom in it. And we have also studied today some examples of polyhalogen compound. The first one was tetrachloromethane, or you can say it is having this structure CCl4. Okay, one carbon, so this is single carbon containing compound, and this carbon is attaching with four chlorine atoms. So this is tetrachloromethane. This is polyhalogen compound. We have talked about this today. Then we have also look upon the polyhalogen compound like freons. Freons is CCl2F2. It is a chlorofluorocarbon, and it is also used as a refrigerant in the cooling systems like refrigeration and air conditions. Then we have talked about the another polyhalogen compound, which is DDT, diaphenyl trichloroethane, and the DDT have this structure, which is having this carbon containing or carbon binding with two different chlorobenzene rings, and this carbon is also binding with CCl3. Okay, so this you can say DDT structure is containing 5 number of chlorine atoms, and this is a polyhalogen compound. Okay, we have seen its uses and its health impacts and also environmental impacts. We have also seen the preparation of DDT, right, from the chlorobenzene and from the aldehyde. Okay, that's all for today's chemistry session. Thank you so much. Thank you.